All right, so now let's take a quick look at aggregate demand and aggregate supply, which will be in chapter 13 of our Jones books. Again, we got a PDF of that on Canvas. And so to start off, we're going to talk about aggregate demand and aggregate supply. Maybe it's helpful to think about aggregate demand and aggregate supply in contrast to just our typical supply and demand with micro. So in micro, we look at the market for one good or service at a time. So for a single good, we're looking at the price of that good relative to the quantity, and so demand curves slope downwards. People buy less of a good when the price is higher, but people want to sell more of the good when the price is higher, so the supply curve slopes upward. Then we'd have this equilibrium here of our equilibrium quantity for this good and our equilibrium price. And so the key thing with micro is really trying to understand for consumers, how much do they want to buy of this good as the price changes? Well, that depends on how willing they are to switch to other goods. So microeconomics is really about this or that sort of question. So for consumers, do I want to buy more of this good, or do I want to buy more of another good as this good gets more expensive? Or for the supply side, it's about the opportunity cost of production. So if we spend our resources producing this good, we're not spending those resources producing something else. If we wanted to, we could exit this industry entirely and decide to instead produce some other good. And so if micro is about this or that, then macro is more about the question of now or later. Because if we think about aggregate demand and aggregate supply, we're looking at not just one good or service, but we're looking at all the goods and services that the economy produces at once. So how much do people want to buy of all the different goods and services in the economy? How much do people want to produce of all the different goods and services in the economy? So it's not so much about producing more of this or that or buying more of this or that. It's about, do we want to spend more resources now or later? Do we want to produce more now, or do we want to produce more later if we decide to store up our inventories and not sell as much now, or if we decide to kind of not use all of our factors of production now and try to produce more in the future? All right, so that's kind of the basic idea. And when we think about aggregate demand and aggregate supply, I made a little notes document. If you go to Module 1 Notes with kind of a helpful summary of some of these formulas, hopefully it'll be a little bit easier to follow when we get into our normal book and start talking about microeconomics, as things kind of just follow in a nice sequential order. But for this one, I thought it might be helpful to have a little bit of background information. So aggregate demand and aggregate supply is really about trying to model short-run fluctuations in the economy, or what we might call business cycles, like the boom and the bust, recessions, and expansions. And so short-run fluctuations, it's really about a few key things here. And so if we take a look at our three equations to start off this chapter, that's kind of a summary of our short-run model. All right, so our first equation is going to be what we call the IS curve. Our IS curve is called the IS curve because that stands for investment equals savings. That's an important macroeconomic principle, which is saying that because savings are where investments come from, in the macroeconomy in the long run, savings should equal investment. And so this is important for driving economic growth. People need to save so that there can be resources invested in coming up with better ways to produce stuff. And so this bridge between savings and investment we call the financial system. That's going to be a key part of the economy. This IS curve is basically about one simple idea. We'll look at a little equation here. The basic idea of this IS curve is that if the real interest rate goes up, that's going to lead to lower investment, and that's going to lead to lower output in the economy. Okay, so this is our real interest rate. And then our output, we're going to have this term here. And this is equal to whatever our output is in year t. This is our real interest rate in year t. And so we have our output in year t. Subtract this, which is our potential level of output. That's how much we can sustainably produce in the long run as an overall economy based on how much labor, human capital, and technology we have. And so really this variable here is percentage deviations in output from our potential output. Okay, so if our real interest rate goes up, we'll produce less relative to potential. If our real interest rate goes down, we'll produce more relative to potential. And really this is about the gap between our real interest rate RT and what should be kind of the natural interest rate in the economy, which is this R bar, which is based on the marginal product of capital. So we looked at the marginal product of capital. That's going to be what should be the interest rate. And so that would be our kind of our long run. So if this is equal to 0, we're going to have output equal to potential output. If this is greater than the marginal product of capital, this R bar, then output's going to increase relative to potential. Okay, so let's take a look at what this IS curve is. And then we'll make sure we understand all the terms here. So the equation looks like this. We have y tilde in year t is going to equal a bar minus b bar times rt minus r bar. And so again, this is our output relative to potential output. So this would be 0 if output equals potential output. And then this would tell us in percentage terms how much higher or lower we are than potential. This is going to be a demand shock if for whatever reason people decide to buy more or less in the economy. So this would equal 0 if we're in our long run equilibrium or our steady state. And then this here is the difference between our real interest rate and the marginal product of capital. So if this goes up, output's going to go up above potential. And exactly how much depends on the sensitivity parameter here, which is really about the sensitivity of investment to this real interest rate. So if our interest rates are going up, that's going to mean that investment goes down, and as a result, our output is going to go down as well. All right, so that's our first equation. Our next equation is going to be what we call our monetary policy curve. This is set by the central bank. In the United States, this would be the Federal Reserve. And in this chapter, we consider a simple rule. We could use more complicated rules. But the basic idea here is going to be central bank is going to increase nominal interest rates. That's what you'd see if you asked for a loan at the bank. And that's going to lead to the real interest rate in the economy changing as well. So raising nominal interest rates will raise real interest rates because prices aren't going to adjust that quickly in the economy. So the real interest rate is the interest rate after accounting for inflation. So this real interest rate should be equal to this nominal interest rate minus the inflation rate here. And assuming that prices aren't going to adjust that fast, if interest rates go up, real interest rates are going to go up as well. All right, so our monetary policy rule is going to look like this. So we have the real interest rate minus the marginal product of capital, or kind of the neutral interest rate, and that's going to equal this. And so here we have that real interest rate minus the marginal product of capital again. And monetary policy is going to increase this interest rate if inflation gets to be above its target. So this is our inflation rate in year T. This is our inflation target. In the US, the inflation target has been for a while 2%. So the idea here is that if actual inflation gets to, say, 5% and our target is 2%, we're going to have to raise this real interest rate in order to kind of slowly fight inflation. All right, so that's the second one. And if we combine these first two, we're going to get the aggregate demand curve. All right, so this looks a little bit like this. So we can look at our IS curve is what's this? Our monetary policy curve was this. Okay, what do we got here? We have M. All right, and this M is just how sensitive the central bank is to changes in inflation. So if this is higher, we're going to raise interest rates more when inflation goes up, and if this is lower, we're not going to respond as aggressively. So if you look at these equations, we can combine this to get the relationship between prices and output on the demand side. And so we can see that we have this term here. So what we can do is we can just take this and substitute it into there since those things are equal. And if we do that, we should get our aggregate demand curve is this. All right, so that tells us on the demand side in the economy how deviations in output from potential output are related to deviations in inflation from our target level of inflation. Okay, all right, let's move on and lastly look at aggregate supply, which is going to come from our Phillips curve. So our Phillips curve is our third equation. And our Phillips curve is basically going to tell us that when output goes down below potential, that's going to lead to lower changes. This is delta for change in the inflation rate. So basically, when consumers demand less output in aggregate, so our aggregate output's going down, that's going to lead firms to lower their prices, but they might not lower them enough for the economy to fully adjust. All right, so the equation for the Phillips curve is going to be this. We have our change in the inflation rate is equal to this V bar times Y tilde D, which is our percentage deviation in output from potential, plus this. All right, so this is our change in inflation, which is YT minus Y, or pi T minus 1. So this is inflation this year minus inflation last year. So that's the percentage rate at which prices are increasing, so that rate of increase is going up compared to last year by this amount. Okay, this is our deviation in output again. This would be an inflation shock, which would be equal to 0 if we're in our long-run equilibrium. We could have some thing that's driving up costs in the economy, like maybe oil prices are going up, or maybe we have supply chain disruptions during COVID. And then this V here is going to be sensitivity of inflation or prices to changes in aggregate demand. So that's going to tell us how sensitive firms in the economy are as they change prices. Okay, so that's really the three equations. And if you put these two together, we should get something like this, where we have aggregate demand So how much we want to spend in aggregate in the economy relative to potential GDP. It's going to be this. And then aggregate supply, we can look at this equation here, and if we just write it like this, so we know that the change in inflation is this. If we say that we already know what inflation was last year, we can write this as a function of inflation this year. And so we'd have this kind of written out as so, just moving the pi t minus 1 over to the other side. Okay. So we'd have inflation this year is inflation last year plus our responsiveness to demand shocks times whatever this demand in aggregate is relative to potential. And then we can have a potential inflation shock here. And so the basic idea is we kind of are going to have something that looks a lot like supply and demand. The difference here is we're looking at output relative to potential on the x-axis in the overall economy, and we're looking at inflation here on the y-axis. And so we should have some equilibrium here. This is our aggregate supply curve. As output goes up, inflation goes up, or as demand goes up, inflation goes up. And then for aggregate demand, as inflation goes up, we actually want to buy less because monetary policy is going to be increasing interest rates and lowering investment and such. And so we want to figure out this equilibrium. And if we look at what we call a steady state, that's kind of where we'd be in the long run. In the steady state, we're going to, first of all, be steady. So inflation is going to be constant. And if this equals this, then we have this should be equal to 0, right? Because those would subtract each other out. So we have 0 equals this. If we're in the steady state, there's no supply or demand shocks. There's no inflation shock here. So this equals 0, which means that this term would be equal to 0, which means that our output equals our potential level of output. So at that point, there's no percentage deviation in this year's output from our potential level of output in the long run. And if that's true, if this is equal to 0, we're going to have no demand shock in the steady state. As a result of that, we know that this must equal 0. And as a result, inflation must be at whatever our target is. So our inflation level here would be equal to our target. And so that kind of gives you a basic idea of how this model works. If you look through the chapter, you should be able to kind of see what happens when we have shocks. So if we do have a shock to either the cost side, an inflation shock, or the demand side, here a demand shock, you can kind of see what happens as demand goes up or demand goes down. You can see what happens if supply goes up or supply goes down. And we can see kind of what happens in the short run and how does the economy dynamically adjust as a result of these equations here. So let me know if you have questions, but hopefully that gives you a little bit of a place to start. And we'll talk to you guys next time.